Dr. Adams wants to start a patient on a heparin drip. The patient weighs 172 pounds. The order is written for 80 units per kilogram as a bolus and then 18 units per kilogram per hour as an infusion. The pharmacy has 5,000 units per ml vial and the bags of 25,000 per 250. How many milliliters is needed for the bolus and how many milliliters per hour should the infusion run at? Round to the nearest tenth for the infusion. Okay, so let's start with the bolus problem. We're going to do dimensional analysis. 80 units per kilogram is for the bolus. Patient weighs 172 pounds. We have to convert that to kilograms. And we know that 2.2 pounds is equal to 1 kilogram. So the pounds is going to be opposite to the pounds on top because they're going to cross out. So then equals to, it's going to be 80 times 172 is 13,760 over 2.2. And 13,760 divided by 2.2 is 6,254.5 units. And I just want to show you how the units cancel out. So kilograms with kilograms, pounds with pounds, and you're left with units. 6,254.5 units. And now we have to figure out how many milliliters. So we have a vial of 5,000 units per 1 ml. That's what the pharmacy has in stock. And again, I just want to repeat, we have a vial, 5,000 units per ml. Very important, pay attention to the concentration. So now we're going to do a ratio, a simple ratio. 5,000 over 1 is equal to 6,254.5 units over X. And then we're going to cross multiply. We're going to do 6,254.5 units times 1 divided by 5,000. Take out your calculators. It gives you 1.25 milliliters. You need 1.25 milliliters to give you the 6,254.5 units. Next, we're going to do the infusion problem. So let's look at the problem again. Dr. Adams, you have a patient who wants to start a heparin drip. Patient weighs 172 pounds. You got to convert pounds to kilograms. Very important. 18 units per kilogram per hour infusion rate. The pharmacy stocks a bag of 25,250. Very important. Pay attention to the concentration. How many ml per hour should the infusion run at? All right, so let's start off dimensional analysis. We're going to set up the equation. We're going to do 18 units per kilogram per hour. So we're going to do the kilogram and the hour we're going to keep on the bottom. Times. All right, so we know the patient weighs 172 pounds. We're going to put 172 pounds over 1. Now we have to change it to kilograms. So we're going to do 2.2 pounds on the bottom because it has to cancel out the units on top, equal to 1 kilogram. And now we have to take care of the units. So we know we have 25,000 units. We're going to put the units on the bottom because it has to cancel out the units on the top. 25,000 units per 250 ml bag, which we're going to put on top. That's what we have. It's the bag that we have in stock. Now we're going to multiply 18 times 172 times 1 times 250. And that gives us 774,000 over 2.2 times 25,000, which is equal to 55,000. So 774,000 divided by 55,000 is equal to 14.07. If we're going to round to the nearest tenth, so that's 14.1. And it's going to be milliliters. And we're going to cancel out the units just to show you how I got the milliliters. We're going to cancel out units with units, kilograms with kilograms, pounds with pounds. You're left with milliliters on top and hour on the bottom. So it's going to be 14.1 milliliters per hour. To repeat, the infusion runs at 14.1 milliliters per hour. And that's the infusion rate. And that's it for this problem. Thank you very much.